In this video, we're going to look at the multiple choice problems on an Algebra 1 Regents exam. The goal is not only to review important topics, but also to develop strategies that may be used on a variety of problems. Even if you feel confident about a problem, I encourage you to stay with me as we will explore multiple techniques and strategies on many problems. Let's get started. Problem 1. Which expression is equivalent to 100x squared minus 16? We see the four choices are factored forms of the original problem. We have a few ways we could approach this. One possibility is to take the original 100x squared minus 16 and rewrite it in factored form. Keep in mind that the answer may not be fully factored. It might be something we see along the way. We begin by taking out the common factor of 4 and then factoring the difference of perfect squares, 25x squared minus 4. We look at the four choices, but nothing really looks right compared to what we've written on the page so far. So let's take another approach. We know 100x squared and 16 are perfect squares, and since they're connected by subtraction, we have a difference of two perfect squares. We could factor this to 10x plus 4 and 10x minus 4. Each of those factors does have a common factor of 2, and we could multiply those 2's to end up with the same answer we got the first time around. But notice the 10x plus 4 and the 10x minus 4 is one of our choices. So that is the expression that is equivalent to 100x squared minus 16. Another approach we could take is to look at all four choices and multiply them out using the distributive property. This is considerably more work, but one of them should come out to be 100x squared minus 16. We see that 3 of them do not, but one of them does, choice 3. Since this comes out to be 100x squared minus 16, that means 10x minus 4 and 10x plus 4 are the equivalent expression. Another option would be a graphical approach. We could graph 100x squared minus 16 on our graphing calculator. Just keep in mind that you're going to have to adjust your window in order to see the graph. Then graph all four choices. See which of those four choices has an identical graph to the original. You'll notice that in all four choices, only choice 3 matches the original graph. Therefore, choice 3 is the equivalent expression. Problem 2. Josie has $2.30 in dimes and quarters. She has 2 more dimes than quarters. Which equation below can be used to determine x, the number of quarters she has? In this problem, we have a couple of things. We have quarters and we have dimes. This problem is about money because we're told that Josie has $2.30. So we know that quarters are worth 25 cents each and dimes are worth 10 cents each. Those quarters and dimes give us a total of $2.30. Now we need to assign variables to represent quarters and dimes. The problem tells us that x represents the number of quarters. Now we need to find an expression to represent the number of dimes. She has 2 more dimes than quarters. We need to put this together in order to come up with some sort of an expression. Sometimes this can be difficult, and if it is, you can always make a table to try to piece things together. Suppose she has 1 quarter. Well, she has 2 more dimes than she has quarters. So 1 quarter, 2 more would give her 3 dimes. If she had 2 quarters, well, she has 2 more dimes. 2 plus 2 would give her 4 dimes. Suppose she had 3 quarters. She has 2 more dimes than quarters, so 3 plus 2 would give her 5. Suppose she has 4 quarters. She has 2 more dimes than quarters, so 4 plus 2 means she has 6 dimes. In each case, notice we are taking the number of quarters and adding 2. So if she has x quarters, then she has x plus 2 dimes. So we'll assign the expression x plus 2 to represent the number of dimes that Josie has. We'll use this information to write our equation. The total amount of money is $2.30. That comes from adding up how much money we have in quarters plus how much money we have in dimes. So the value of the quarters plus the value of the dimes will equal $2.30. How much is each type of coin worth? Well, the quarters, 25 cents each, times however many we have, 0.25 times x, plus the value of the dimes. The value of the dimes are 10 cents each, times however many we have, so 10 cents times x plus 2. That equals $2.30. We now have our equation. That equation matches choice 3, and so we've answered the problem. If we wanted to determine how many quarters or dimes she had, we would continue solving the equation, but for now, this problem is done. Problem 3. If g of x equals negative 2x squared plus 16, then g of negative 3 equals which of the following? Remember, when we have a function, we have f of input equals output. In this case, our function's name is g, and we have the input negative 3, and we want to find the output. We have a few ways that we could do this. The first would be an algebraic approach. Simply write down your function and replace the variable x with the input negative 3. If you're going to evaluate this by hand, be careful and make sure you use the order of operations, PEMDAS. Negative 3 squared is negative 3 times negative 3, 9, times negative 2 is negative 18, plus 16 is negative 2. In function g, the input negative 3 produces the output of negative 2. G of negative 3 equals negative 2, which is choice 2. If you don't want to do the computations by hand, you can always type them into your calculator. If you do that, be careful. Make sure you put the negative 3 in parentheses and the exponent of 2 on the outside. If you don't use those parentheses, as seen here, then the calculator will give you an incorrect answer. And notice that that incorrect answer is choice 3. So be very careful. One other option we have is to use the graphing feature of our calculator. Go into the calculator, add a graph, and enter the function negative 2x squared plus 16. Then open up the input and output table. Go on the table to find the input of negative 3 and see what the corresponding y value or output is. When the input is negative 3, the output is negative 2. That's choice 2. Remember, if you don't want to scroll up and down the table, or if your input is a fraction or decimal, you can always change your table settings by hitting the menu button, edit table settings, and then change the independent variable to ask. When you do this, you'll be given an empty input and output table where you can type in any input you want. Type in the input negative 3, and the output is negative 2. Choice 2. Problem 4. What are the zeros of f of x equals x squared minus 8x minus 20? Remember, the zeros are where the graph crosses the x-axis. In this function, there are 2 of them. There are different approaches we could take to find this. Remember that the zeros are where the y values or the outputs are 0. So one approach we could take to this problem is to factor the function, and then set each factor equal to 0 and solve for x. Our function is a trinomial. We're looking for numbers that multiply to negative 20 and that add to negative 8. Those numbers are negative 10 and 2, and so that helps us create our factors, x minus 10 and x plus 2. We write each factor equal to 0 and then solve for x. X equals 10, x equals negative 2. Those are the zeros of the function. Choice 2. Remember, the choices could also be written using set notation, where they use the squiggly brackets and they list out the zeros or the solutions in numerical order, negative 2, 10. Another approach we could take is to graph the function using our graphing calculator, and then use the features within the calculator to find the x-intercepts or the zeros. When the function appears, it's always a good idea to click on the label that shows the equation and hit the delete key to give yourself more working space. Then adjust your window so that you can see more of the function. There are 2 zeros on this function. We'll use the menu, Analyze Graph, and then 0. The calculator will give you the finger with the dashed line so that you can shade over each of the zeros one at a time. You have 2 zeros, -2, 0, and 10, 0. The x values are the zeros of the function, so our zeros are 10 and -2. Looking at the 4 choices given to us, 10, 2, -2, and -10, one other possibility we have is to go into the table and check those x values to see if they have an output of 0. -10 has an output of 160. It is not one of the zeros. -2 has an output of 0. That is one of the zeros of the function. 2 has an output of -32, so 2 is not one of our zeros. And +10, 10 has an output of 0. That also is a zero of the function. The zeros are 10 and -2. Problem number 5. Which point lies on the graph of y equals 3x squared minus 1/4 x plus 3? We want to know which point is on the graph, so we might as well go directly to the graph. Enter that function in your calculator, and then look at the input and output table. See which of those points is in the table. Of the 4 of them, only the first one, -2, 15.5, is listed in the table. The points listed in the table are the points on the graph, and so the point on the graph is choice 1. If you don't want to scroll up and down the table, or if some of the inputs or x values were decimals or fractions, you can always edit your table settings. Menu, Edit Table Settings, and change the independent variable to ask. That will give you a blank input and output table where you can type the 4 x values to see the y values that go with them, and then match to see which one is the point on the graph. Choice 1. Another option, which would take considerably more time, would be to remember that points that are on the graph are the values of x and y that make the equation true. We could take each of those points, identify the x and y, substitute them into the equation, and see which x and y pair makes the equation true. Only one of them makes the equation true. That is choice 1. Problem 6. Given f of x equals x squared and g of x equals 8x minus 15 graphed on the same set of axes, which value or values of x will make f of x equal to g of x? Whenever they ask us where f of x equals g of x, they're asking us to find the x values of the intersection points. We enter the first function in our calculator and look at its graph. We then hit the tab key, enter the second function, and then see both graphs together. To give ourselves more space, we click on each of the equations that are displayed on the screen and hit the delete key so that we have more working room. We need to adjust our window so that we can see the intersection, which looks like it appears on the top part of the functions. When I zoom out, I do see one intersection very clearly, but I'm not too sure what happens further up. If I zoom out further, I'll notice that there are actually 2 intersections, so I want to make sure I capture both of them. We're looking for the points of intersection. Menu, Analyze Graph, Intersection. The calculator will give you the finger with the line so that you can shade over each intersection. There are 2 intersections. You must do this process for each one separately. We have intersections at 3, 9 and 5, 25. The x values, x equals 5 and x equals 3, are the values of x that make f of x equal to g of x. That is choice 3. Notice a point of danger here. If we had not zoomed out further and we had missed the point 5, 25 and only found 3, 9, we might have thought the answer was only x equals 3, which is the first choice. So always zoom out more and see what's going on. Problem 7. Which trinomial is written in standard form and has a constant term of 5? Remember, standard form is when our terms are written with the largest exponent first to the smallest exponent. The constant term is the term or the number that has no variable. Here are 4 choices. Choice 1, standard form. The exponents are 5, 2, and none. That passes the first test. The constant term is 10. We want a constant term of 5, so choice 1 is not our answer. Choice 2, we look at the exponents. 2, 4, 5. Those are not going in order from largest to smallest. This is not in standard form, so it is not our answer. If this were written in standard form, do notice that the constant term would be 5, so be careful. The third choice, the exponents are 4, 2, and none. That is in standard form, but unfortunately the constant term is 1, meaning choice 3 is not our answer. The final choice, 4, has exponents 5, 2, and none. Those are written in standard form, and the constant term is 5. Choice 4 is our answer. Problem number 8. When solving x squared plus 6x minus 8 for x, a student wrote x squared plus 6x plus 8 equals 0 as their first step. Which property justifies this? There are 4 properties. Let's take a moment and make sure we know what they mean. The associative property says that when adding or multiplying any 3 numbers, you can group any 2 of them together first. The commutative property says when adding or multiplying numbers, you can change their order. The zero property of addition says that when you add 0 to any number, the value is unchanged. And the addition property of equality says that you can add the same amount to both sides of an equation. Take the 2 steps given to us and write them one above the other. Look to see what has changed. The change from the first to the second step is in the pink box. What has happened? Well, the student added 8 to both sides. The addition property of equality. Choice 4. Problem 9. The tables below show the input and output values of 4 different functions. Which table represents a linear function? Notice that the choices are f of x, g of x, h of x, and j of x. The name of the function is shown in the y column of each of the tables. Linear functions have a constant rate of change. That rate of change is called the slope. An easy way to test this, if your x values go up by a consistent amount in each table, is to simply take any y value minus the y value before it. If this is a linear function, then that difference will always be the same. If the x values do not go up by a constant amount, then you'll have to use the old slope formula, y2 minus y1 over x2 minus x1. We look at our first table. The x values are increasing by 1 each time, so we can use the simple test. Each y value minus the 1 before it. 1 minus 6, negative 2 minus 1, negative 3 minus negative 2, negative 2 minus negative 3, and 1 minus negative 2. We notice we get a different result each time. Because it is not a constant amount every time, this is not a linear function. Use extra caution when dealing with those double negatives, work carefully, and work slowly. Now let's look at the second table. Again, we're going to use the test because we notice that the x column is increasing by 1 each time. We have a constant amount there. 2 minus 3, 1 minus 2, 0 minus 1, 1 minus 0, and 2 minus 1. The results were the same for a little while, negative 1, but then they changed to positive 1. This is not constant, and therefore this is not a linear function. Do be careful. If you had only tested the first 2 or 3, you might have accidentally thought that this was the linear function. It's important to test the entire table. Let's look at the third table. Again, the x column goes up by a constant amount each time, 1, so we can use our simple test. Negative 2 minus negative 1, negative 4 minus negative 2, negative 8 minus negative 4, negative 16 minus negative 8, and negative 32 minus negative 16. This is not a constant amount each time, therefore this function is not linear, which means we hope that the fourth table will be our linear function. We look at the x values. The x values increase at a constant rate, adding 1 each time. So now we can use the simple test. Each y value minus the 1 before it. -7 minus -11, -3 minus -7, 1 minus -3, 5 minus 1, and 9 minus 5. Each time we find the difference is 4. We have a constant rate of change, therefore this function is linear. The name of this function is j of x, which is choice 4. Another option you would have would be to plot each of the table's points on a graph and look at the shape of those points. You could do this by hand on a piece of graph paper, which is at the back of the exam, or if you know how to use your graphing calculator, you could enter each table into the calculator and then look at the data and statistics screen to see the shape of the points. We can see that the points are all different types of shapes. The first one is quadratic. The second appears to be absolute value. The third appears to be an exponential. And the fourth is a linear function because the points are all in a perfect line. Again, the function j of x, choice 4. Problem number 10. What is the solution set to the equation 3x squared equals 24x? This is a quadratic equation because it has x squared in it. Quadratic equations must equal 0, so we begin by subtracting 24x from both sides. Once we have set the equation equal to 0, then we can use any method we'd like. We're going to use factoring here. There's a greatest common factor of 3x, leaving us with x minus 8 in the parentheses. Set each factor equal to 0, and then solve to get the solutions to the equation. This equation has two solutions, x equals 0 and x equals 8. Notice the four choices. They are written in set notation with the x values written within the squiggly brackets. We are looking at choice number 2 as our answer. Another option, with our equation equal to 0, would be to solve the equation by graphing. Simply go into your calculator, create a graph, and enter 3x squared minus 24x. Delete your label and adjust your window, and then find the zeros. Menu, Analyze Graph, 0. Calculator gives you the finger so that you can shade the first 0. Repeat the process for the second 0, and now you have your solutions to the equation, x equals 0 and x equals 8. Since this was multiple choice and written work isn't mandatory, this was a terrific way to solve this equation. There is one more option we could take to find the solution set to this equation. Because this is multiple choice, and they give us possible solutions in those choices, 0, 8, and -8, we can use the fact that solutions make equations true to determine which values in fact do make this equation true. So we could take the equation and substitute each value in to see which one makes it true. When x is 0, I end up with 0 equals 0, which is true. So x equals 0 is a solution. When x equals 8, I end up with 192 equals 192. This is true. And so x equals 8 is a solution. When x is -8, I end up with 192 equals -192. This is false. Therefore, x equals -8 is not a solution. The two solutions to the equation are 0 and 8, choice 2. Problem 11. The table below shows the radioactivity level of a substance after the given time, t in seconds. What is the average rate of change in radioactivity level over the interval from 1 to 3? Whenever we see the words average rate of change, we should instantly think of the slope formula, y2 minus y1 over x2 minus x1. In order to use this formula, we need 2 points. The interval 1 to 3 gives us our x values 1 and 3. The y values come from the table. When x is 1, y is 10. And when x is 3, y is 2.5. Those numbers go into our points. We label them x1, y1, x2, y2, and then substitute them into the formula. At this point, you can either calculate it by hand or type them directly into your calculator. When we do that, we see the average rate of change is negative 3.75. Choice 2. Problem 12. Fred recorded the number of minutes he read each day from Monday through Friday. His results are shown in the table below. The X column shows the day number. The Y column shows the number of minutes read. What is the correlation coefficient to the nearest thousandth and the strength of the linear model of these data? Remember, correlation coefficient represents the strength and direction of a linear relationship. Correlation coefficients can be positive or negative. When the correlation coefficient is positive, the data generally has an upward trend or is generally increasing, although the points may not be in a perfect line. When the correlation coefficient is negative, the data is trending in a downward direction or generally decreasing, although again, the points may not be in a perfect line. Correlation can be strong or weak. Weak correlation is when the correlation coefficient is relatively close to zero. Notice the graphs below the pink box. Those data points are not very linear at all. They have weak correlation. As correlation gets closer to -1 or +1, it becomes a stronger linear relationship. If you notice the graphs below the pink boxes now, you'll see that as we get further away from zero, or closer to -1 or +1, the lines become closer and closer to being linear, up to the point that they're perfect at the very ends. We want to find the correlation coefficient. We begin by going to our calculator, adding a list in spreadsheet, and then going up to the top box A and naming that column A, hit enter, go over to box B, name that column Y and hit enter, and then carefully enter the data in the table. Be sure to hit enter after entering every value and double check to make sure that your numbers match the table printed on the page. If you have even one value entered incorrectly, things will not turn out right. Once we've entered the data, we use Control plus page or Control I to insert a new page. We add a calculator. Menu, Statistics, Stat Calculations, Linear Regression MX plus B. The calculator asks for the name of the X column and the Y column. We named them X and Y. Go down and click OK, and you'll see this displayed on your screen. The R value is the correlation coefficient. Be careful, R squared is also there, and that is not the correlation coefficient. But do be careful because you'll notice that two of those choices have the incorrect value listed. We're now looking at choice 1 and choice 3. Is this data strong or weak? If the number is close to 0, it is weak. If the correlation coefficient is closer to positive or -1, the data is strong. 0.984 is very close to 1, therefore the data is strong. 0.984 and strong, choice 1. Problem 13. Given f of x equals x squared, which function will shift f of x to the left 3 units? There's a couple of ways we could do this. The first involves understanding the shifted form of a function. When we have a function, the number inside the parenthesis shifts us to the left or to the right. It's the opposite of what we think. If we have plus a number inside the parenthesis, we shift to the left. If we have minus a number inside the parenthesis, we shift to the right. The number at the end shifts us up and down. Plus a number is up that many units. Minus a number is down that many units. We look at our 4 choices. Choice 1 has plus 3 at the end. That shifts the function up 3. We want to shift left 3, and so choice 1 is not our answer. Choice 2 has minus 3 at the end. That shifts us down 3. Again, we're looking to move to the left. Choice 2 is not our answer. Choice 3. We have minus 3 inside the parenthesis. Inside the parenthesis is our left and right movement. It is the opposite of what we think, so minus 3 would actually shift us to the right 3. We want to move to the left. Choice 3 is not our answer. In the fourth choice, we have x plus 3 in parentheses. Again, inside the parenthesis is our left and right movement, and the opposite of what we think. Plus 3 means we move to the left 3, which is exactly what we want. Choice 4 is our answer. A second approach you could take to this problem is to use your graphing calculator. Graph the given function f of x equals x squared, and then graph all 4 choices. Look at the shift and determine which one has moved to the left 3 units. When you analyze the graphs, you'll notice that only one of the graphs moved to the left 3 units. That is choice 4. Problem 14. A class of 20 students was surveyed to determine the number of pets each student owned. The data are represented in the dot plot below. You'll notice the dot plot has numbers along the bottom and then dots up above them. The dots represent how many students have that corresponding number of pets. The 1 dot above 0 means 1 student had 0 pets. The 4 dots above the number 1 means 4 students had 1 pet, and so on and so forth. We want to determine which statement is correct. All of the statements are comparing the mean, the median, and the mode. The mean is the average, the median is the middle, and the mode is the most often. The mode is perhaps the simplest of them to calculate, because all we have to do is look at the dot plot and determine which value has the most dots. The most dots appear for the number 2, so the mode of the data is 2. Next, let's calculate the median. The median is the middle value. We would have to list all of the numbers out. 0, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, and so on and so forth, listing each number for each dot. We then count our way into the middle to find which number lies in the middle. If it's a single number, it's simple. That's the number we have. If there's a tie, we simply average them. Both numbers are 2. The average of 2 and 2 is 2. So the median is 2. Now we need to find the mean, the average. The average is when we take all of the numbers, add them up, and divide by how many there are. When we add all 20 of those numbers up, we see that they add up to 50. There are 20 numbers altogether. 50 divided by 20 gives me an average, or a mean, of 2.5. Looking at the choices, the mean is different than the median and the mode. The median and the mode are the same, which is choice 2. If you don't want to calculate these values by hand, you can always use your graphing calculator. You can start a new document, add a list in spreadsheet, go up to box A and name the column X, and then carefully type all of the numbers in. Now, add a new page with Control plus page or Control I to insert a new page. Add a calculator. Menu, Statistics, Stat Calculations. One variable statistics. The calculator will ask you how many lists you entered. We only entered 1 list, so we hit OK. Now they ask you for the name of that list. We named that list X. Click OK, and the calculator will give you a summary screen. X bar, the X with the line over the top, is your mean. Median is listed as median X. Mode you would have to get from the dot plot by looking for which one occurred the most often. Now that you have your 3 numbers, you can conduct your analysis and choose the choice that matches what you find. Exercise 15. The range of f of x equals absolute value of x plus 2 minus 5 is which of the following? Here we have a function. It is written in shifted form. The function has shifted to the left 2 and down 5. If we sketch that graph, we have a function that looks like this. We want to find the range. The range is the y values, the minimum to the maximum, or the low to the high. The lowest y value is -5. The graph goes upward forever to infinity. The range is -5 to infinity. This is how we write it using interval notation. However, none of the four choices are written in interval notation. They're written as inequalities. So, as an inequality, we would have to write y is greater than or equal to -5, which is choice 1. Do be careful. Range is y values, not x values. If you accidentally write x, you might choose choice 3 in error. Be cautious. If you weren't sure about the shift left and down, you could always go to your graphing calculator. You could graph the function and then find the minimum by going Menu, Analyze Graph, Minimum, shading over the minimum point, and then hitting Enter. The minimum is at the point -2, -5. Again, because range is y values, we're interested in the y. The lowest y value is -5, and the graph goes up forever. Be careful of that -2. Notice that choice 2 and choice 4 both include the number 2, which are meant to distract you. Problem 16. Which equation is always correct? These equations involve the exponent rules. Remember the exponent rules. When we multiply things that have the same base, the base is the thing that has the exponent, we add those exponents together. When we have an exponent outside of a parenthesis, we can distribute that exponent in to the exponents that are inside. These rules are what are going to allow us to determine which equation is correct. We look at the four choices. Choice 1, a to the third times a to the x. I would add those exponents together. That would be a to the 3 plus x, not a to the 3x. That is an incorrect statement, so choice 1 is not the answer. Choice 2, I have a to the 4 to the x. When I have a power raised to a power, I can distribute the exponent in. So that would be a to the 4x, not a to the 4 plus x. Choice 2 is not correct. Choice 3, I have an exponent outside of a parenthesis. I can distribute that exponent in to both terms inside, a to the 1x times b to the 1x, which is just a to the x, b to the x. That does match what was given to me. That is a valid equation. And choice 4, we cannot add those exponents together because they are not the same base, a and b. So choice 4 is not correct. The answer is choice 3. If you don't want to deal with the exponent rules and you want something a little bit simpler, you can use your graphing calculator to accomplish this. You can choose values for each variable and then use the calculator to see which equation is true. These can be any numbers you want, although I would avoid using the number 0 and I would avoid using the number 1. Suppose I decide a will be 2, b will be 3, x will be 4, and y will be 5. I'm going to use the stove feature in my calculator to assign these numbers to these variables. How do I do that? Well, on your calculator, you'll notice there's a button that says STO above it. That is the button that you'll use to assign a value to a letter. We would use Control and then that key in order to do this. I assign the numbers one at a time. I type 2, Control STO A, hit Enter. And now anytime I type the letter A, the calculator will assign the number 2 to it. 3, Control STO B, Enter. And now anytime I type the letter B, the calculator will assign the number 3 to it. I do the same for 4 and for 5. And then I begin typing my equations in one at a time to see which one is true. When I type the first one in, a to the third times a to the x equals a to the 3x, the calculator tells me that's false. That equation is not true for those values, and therefore the equation is not always correct. I then try the second one. Again, false. This equation was not true for the numbers that I picked, and therefore the equation is not always correct. The third choice tells me true. Now, this true doesn't necessarily mean it's always correct. It means it's correct for the numbers that I put in. I still have to check all the other choices to make sure they say false. If they do say false, then I will have found my answer. But if more than one of them comes up true, I'll have to pick some different numbers and test those two equations again. One important thing to note: when typing the A, B, make sure you put the multiplication dot between them, A times B. Otherwise, the calculator will error out. I test the fourth one. That one is also false. So choice 3 is my answer. Problem 17. The formula for the area of a trapezoid is A equals 1/2 h times b1 plus b2. The height h of the trapezoid may be expressed as which of the following? We want to solve for h, and we're going to use inverse operations. I always begin by writing down the equation and putting a box around the variable I want to solve for. I want to get rid of that fraction, and so I begin by clearing the fraction out by multiplying both sides of the equation by 2. On the right-hand side, the 1/2 and the 2 cancel out. They multiply to 1 effectively. On the left, I have 2a. On the right, I have h times b1 plus b2. Once again, I'm trying to solve for h, so I put a box around the h. There is a parenthesis on the right-hand side with the h. That parenthesis is being multiplied by the h, and so I will divide both sides by the parenthesis in order to get h alone. I divide by b1 plus b2, so the parenthesis cancels out on the right-hand side, leaving me with 2a over b1 plus b2 on the left and h on the right. My final answer matches choice number 1. Problem 18. 3 functions are given below: function f of x, g of x, and h of x. Which functions have the same y-intercept? In order to do that, we must identify the y-intercept for each. We know that the y-intercept is when x equals 0. So if we look at the table and find where x is 0, the y value gives us the y-intercept. For function h, shown in the table, the y-intercept is -3. Now, the two other functions, we have a couple of choices. One choice is we can use the idea that the y-intercept is when x is 0 and simply substitute 0 in place of x. Use that to calculate the y value. For function f, the y-intercept is 5. In function g, I do the same. I substitute 0 in place of x and I evaluate. The y-intercept is when x is 5. Two of the functions have the same y-intercept. One of them has a different y-intercept. Looking at the 3 choices, function f of x and g of x have the same y-intercept, which is choice 1. If you don't want to go through the trouble of substituting 0 in place of x, you could always graph both of the functions f of x and g of x separately, look at their table, and find the y value when x is 0. For both of those functions, when x is 0, y is 5, and so those are the y-intercepts for those two functions. Again, f of x and g of x have the same y-intercept. H of x does not. In problem number 19, the sum of x plus 7 squared and x minus 3 squared is which of the following? We know that sum means addition, and we have 2 parentheses squared. Be careful, we have to do this properly or we're not going to get the correct answer. X plus 7 squared and x minus 3 squared have to be dealt with appropriately. We deal with them appropriately by writing out the 2 sets of parentheses for each, and then using the distributive property, doing the multiplication, and then combining like terms. 2x squared plus 8x plus 58. Choice 3. Problem number 20. The product of 2 square roots of 10 and 3 square roots of 2 is which of the following? A couple of ideas for this. First, remember that product means multiplication. So we are multiplying 2 square roots of 10 and 3 square roots of 2. When we multiply the outsides, which are called the coefficients, We multiply the insides, which are called the radicands, and then we simplify the square root. 2 square roots of 10 times 3 square roots of 2. 2 times 3 is 6. 10 times 2 is 20. 6 square roots of 20. Now we have to simplify the radical. We'd look at our list of perfect squares, find where 20 would be on that list, and then divide 20 by each of the perfect squares, starting with 16, then trying 9, and then 4. 4 times 5 is 20. So the square root of 20 is square root of 4 times the square root of 5. The square root of 4 is a perfect square, 2. So 6 times 2 square roots of 5 is 12 square roots of 5. Choice number 1. Another way you could deal with this problem, as long as you know that product means multiplication, is to use your calculator. We simply enter 2 square roots of 10 times 3 square roots of 2 in the calculator to find the approximate equivalent decimal. Then put each of the 4 choices into the calculator and see which one or ones match the original. If only one matches, then you found your answer. That's what happens in this case. If more than one came out to be the same, that means one of them is not in simplest form, and you would have to look a little more closely. Problem 21. When 6x to the third minus 2x plus 8 is subtracted from 5x to the third plus 3x minus 4, the result is which of the following? Notice we have a danger word, subtracted from. From is a dangerous thing. A subtracted from B would be written as B minus A. In other words, the two trinomials that you're subtracting will be written in the opposite order of what you think. 5x to the third plus 3x minus 4 is what we start with, and then we are subtracting from that 6x to the third minus 2x plus 8. Remember to distribute the subtraction sign as a -1. So you have 5x to the third plus 3x minus 4 minus 6x to the third plus 2x minus 8. Identify your like terms, combine them, and you'll have your final answer. -x to the third plus 5x minus 12. Choice number 3. Problem 22. 3 relations are shown below. Which relations represent a function? Remember that in a function, each input produces exactly one output. The inputs are the x values, the outputs are the y values. In the first relation, we have a set of ordered pairs, with the x's and the y's, the inputs and the outputs. The input 0 produces an output of 1. The input 1 produces an output of 2. Input 2 produces an output of 3. And the input 3 produces an output of 4. Each input has one and only one output. Therefore, number 1 is a function. The second relation is already written as a mapping diagram. The inputs are on the left, the outputs are on the right. The input 3 has an output of 3. The input 4 has an output of 4. The input 5 has an output of 5, and the input 6 has an output of 6. In each case, each input produces one and only one output, so relation number 2 is a function. Relation number 3 shows us a graph. To test the graph, it's easiest to use the vertical line test. To use the vertical line test, simply draw a vertical line on the graph and move it across to see if it touches the graph more than once at any given location. One way you can do this on paper is by using a ruler and tracing it from side to side. So far, the graph only hits the red line once, until we get here. We notice there's a possible violation. The top point is a closed circle, so that point is clearly on the graph. The bottom point is an open circle, which means nothing here, so although it looks like there's a possible violation, we do pass the vertical line test here. We continue moving across until we see another potential violation. But once again, the top circle is open, meaning there's nothing there. The bottom circle is closed, so there's only one point at that location. We continue across the graph. We see the same scenario here. One closed circle, one open circle. Open circle means nothing there. There's only 1 point at that location on the graph. We continue across to the end, and we have not had any violations. Our graph passes the vertical line test and therefore is a function. Which relations represent a function? All 3 of them, 1, 2, and 3. Choice 4. Problem 23. The method of substitution was used to solve the system of equations. Which equation is a correct first step when using this method? First of all, we have many methods we can use to solve a system of equation. They specifically told us here that we use the method of substitution. This means that we must solve one of the equations for either x or y, and it doesn't matter which equation. But as a general rule, we look for whichever one requires the least amount of work. And the second equation would be very simple to solve for x or y because neither variable has a coefficient. So let's start there and see if when we solve for x or solve for y, if we get one of our choices. If we don't, then we can always test the first equation and see what happens. Let's start by solving for x. We begin by adding y to both sides. X equals y plus 1. This is not one of my 4 choices, so this one's not going to do me any good. So let's see what happens if we take the second equation and this time solve for y. Subtract x from both sides, divide by -1, y equals x minus 1. Is that one of our choices? We look closely, and it is, choice 2. And so we found an equation that is a correct first step when using the method of substitution. Problem 24. In 2009, Usain Bolt, a sprinter from Jamaica, set the world record in the 100-meter dash with a time of 9.58 seconds. His approximate speed in kilometers per hour can be found using which conversion? We want to see which of these conversions works out to give us kilometers per hour. We're going to look for identical units between the numerator and denominator. For instance, feet in the numerator and feet in the denominator, and if we have them, we'll cancel those units. We want kilometers per hour, which is kilometers over hours. Our final answer should have only kilometers in the numerator and only hours in the denominator. We begin with choice 1. We see we have seconds in the numerator and denominator. We cancel them out. We see we have meters in the numerator and denominator. Those cancel out also. We also see that we have minutes, numerator and denominator, and what's left is hours in the top and kilometers in the bottom. That's close to what we want, but we want kilometers in the top and hours in the bottom. This is hours per kilometer, not kilometers per hour. Choice 1, while close, is not our answer. We follow the same process in the second choice, canceling the seconds, canceling the minutes. I do see that I have 2 units of meters, but they're both in the numerator, so they do not cancel. What I have left here is meters times meters in the top, meters squared, and kilometers and hours in the denominator, kilometers times hours. That is not even close to what I want. Choice 2 is not the answer. Choice 3, again, I look for identical units in the numerator and in the denominator. I notice again I have seconds, 2 units of them, but they're both in the denominator, so they do not cancel. We have kilometers and hours in the numerator, seconds times seconds, so seconds squared in the denominator. Again, this is not even close to what I want, and so choice 3 is not the answer. We do the test on choice 4. We cancel our meters, we cancel our seconds, we cancel our minutes. What's left in the numerator is kilometers. What's left in the denominators is hours. The fraction bar is read per, so we have kilometers per hour, kilometers over hours. That's exactly what I'm looking for, and so the answer is choice 4. These strategies will serve you well on the Regents exam. You can find more resources on our webpage at www.dorypublications.com, including algebra handbooks and additional tutorial videos. We wish you great success on the Regents exam.